Yes. So welcome back, students. This is the last video of the first chapter. So almost I think 60 plus videos have been uploaded on the organic chapter, that is the first chapter, haloalkanes, haloarenes. Basically I concentrated on three important concepts, that is your concept, your question and your answer, right? So your concepts first cleared. I have given you questions based on board pattern. And I also gave you answers how to write or how should you write in the exam so that it is precise in the exam and it's easy to correct and up to the mark. Now, how should you plan for studying all these videos? Yes, basically I've been uploading almost maximum of 9 and minimum of 4 videos per day. So I'll be doing it. This will continue till Jan 15th. From Jan 15th till your February end, I will be doing your board papers along with your sample papers. So how should you study for your exam? Understand, time is very precious for us. We don't have time to waste, right? Please don't waste your time for sitting with your mobiles. Whatever questions I am uploading every day, please pick up a notebook, right? You pick up, just write your chemistry, name it as chemistry notebook and start noting all the questions. Put the date, right? I've started on 17th September, right? Keep noting 17th September, question 1, 2, 3 and so on. Right, like that, day wise note it in your notebook and finish off your study on that day only. Remember, we don't have time, so finish off your study as soon as the video is uploaded. Go through the topic, finish off your answer, and once this answer is done, suppose your grasping skills are very high. Once you complete all the videos, now I said 60 plus videos for this because I have gone into the depth of every topic. Now once it is done, on the weekend day, take out your NCERT textbook, yes, and please read the lesson once again. When you read the lesson once again, you will have, because already you have studied all the question answers, you will find it so easy that your reading will be done in just 5 or 10 minutes. If I say okay, maximum 15 minutes. So, but this assurance I can give you only if you study or watch the videos on daily basis. If you watch the videos, okay, fine, today 5, done, tomorrow 5, done. So this will be a habit till February or January 15th or 20th. Once you are done with that, your syllabus or preparation for your boards will be perfect. I give you that assurance. So please go through the videos. Don't waste time. Your target is every day 5 to 9 questions solved. Once you are done, then only please go to the next topic. Don't wait for tomorrow to add on that 5 plus 5, 10. Don't do that, please. Thank you for watching the first. Right, now let's see the next question in this particular reduction. So this very famous question here. Let's read this. What is the role of red phosphorus in the reduction of ethyl iodide? Okay, they said whenever you're taking ethyl iodide, done. Let me take that ethyl iodide, done. You're trying to reduce it in the presence of red phosphorus. Okay, you're trying to reduce it in the presence of red phosphorus. What is the temperature? 423 Kelvin. Right. So first important thing you should remember, whenever there is or whenever you are trying to reduce ethyl iodide, that particular reaction is a reversible reaction. Done. Now let's see what products are we going to get. I'm going to take HI. There's a cleavage of bond here. There's a cleavage of bond. Hydrogen gets added and iodine comes out. So I'm going to get C2H6 plus iodine. Done. Now what happens? The role of red phosphorus, that is what asked me, right? So this red phosphorus, what happens? It's going to combine with this iodine and it will allow the reaction to go to the forward direction. Here what's happening? I said reversible reaction, but basically I want this product. I want ethane. Suppose if you are not adding red phosphorus here, the reaction starts in the reverse order. Again it will form reactants. This will go to the backward direction. So what is this role? First role is when I have to write in the exam, role of red phosphorus. What is that? It allows the reaction to move in forward direction. This is the main thing. Okay, forward direction done. What is the reaction now? This iodine, this phosphorus combines with iodine. So it's going to form a product called Pi3. Now let's balance this. Now 2, 3, 2. 2 phosphorus, 2 phosphorus, 3 to the 6 iodine, 3 to the 6 iodine. So when it's combining or when it's trying to form a compound, phosphorus triiodide, it will block iodine. When it's blocking iodine, what happens? The reaction proceeds only in the forward direction. It will not go back. Thus, we get the required product. So this is the question, and this is the reduction of alkyl halides. So hope you would have seen the order also. So students, let me meet you again with the next reaction. We've already seen the structure of all the reaction intermediates. And now let us note one important thing in our book. Where are the reaction intermediates and which case are they formed? So basically, carbocation when I take, let's write that. So carbocations are formed in which type of reaction? Carbocations are formed in SN1 reaction mechanism. That is unimolecular nucleophilic substitution reactions. Carbocations are formed in even reactions. They are also formed in electrophilic addition reactions. Like electrophilic means the addition molecular reactions. Which are the reactions? Those reactions I can tell you. Those are pinnacolone rearrangement reaction. Rearrangement reaction. This is where it is formed. Suppose if I speak about carbenes. Carbenes are basically formed, or they are released or formed as a reaction intermediates in Riemann-Tiemann reaction. You have studied this, isn't it? In aldehyde chapter, Riemann-Tiemann reaction. Then it is also formed as a reaction intermediate in carbylamine reaction. So carbylamine reaction in amines chapter we have seen. It is also formed as a reaction intermediate in Wolff's rearrangement reaction. It also forms as a reaction intermediate in Wittig reaction, where two rings combine in the presence of sodium and dry ether. Right? So please remember this. Reaction intermediates, their structure and the formation, which type of reactions. come back and solve your 2012 paper. What did they say? Draw the structure, draw the molecular structures of the following. Okay, as I said, the structures are compulsory asked in every paper. And so I've done this XCF6 structure in video number 52, and this structure, there is oxo acids of sulfur in video number 99. Done. Let's come back. Explain the following observations. NH3 and NF3 have dipole moments which are of opposite direction. A bit different question. It's easy to answer. Let's see. So they've given me NH3 and NF3. Okay, done. Fine. First, let us draw the structure. NH3. Okay, lone pair is already there. NF3. Okay, now what actually is a dipole moment? When you represent a dipole moment, how should the arrow be? The arrow should follow. How should this point be? When you're ending the arrow, whichever is more electropositive, that arrow will go towards that. Okay, right here, just observe carefully. Whichever is what did I say? Yeah, more electropositive, that will go towards that arrow. Now in this case, we are going to see this electronegativity value. Yeah, so now what happens? Hydrogen is less electronegative than nitrogen. So the arrow just points this. Now in this case, when I have to see, the arrow points in this direction. Now see, this is more electronegative. Done. This is electropositive. Done. So the arrows are pointing towards in this direction, and here the arrows are pointing downwards. So just write down, this is more electronegative, hence it drags the electron density. This is more electropositive, so this goes down. Done. So because of this, the dipoles are opposite direction. That's why they have dipole moments which are of opposite direction. Done. The next question, all bonds of PCl5 are not equivalent. I did this in 2009 paper, and this question, sulfur in vapor state exhibits paramagnetism. I spoke in terms of antibonding orbitals in vapor phase. So I did that question in 2008 paper. Solve your 2008 paper. This is 2008 paper. Again, basically the chapters for 3 marks given. So both the questions. Let us read the first question. What is a ligand? And give an example of a bidentate ligand. Okay, I clearly explained this question earlier. One is in video number 6 and one is in video number 4. So the main aim for me separating the thumbnails is for this questions only. Questions will be given. I just seen different board papers, and basically whichever question is very important for you all, it will be given listed under the thumbnail. Directly go to that, click that, go learn that easily and attempt the question. So please watch this video for the question, video number 6 and video number 4. Let's come back and see. They've asked me, explain as to how the complexes of nickel tetracyanide, let us hear tetracyanonucleate complex and tetracarbonyl nucleate complex have different structures. Here this is one strong field ligand, this is also a strong field ligand. The central metal atom nickel is same, here also nickel is same, but they have different structures, okay, but do not differ in the magnetic behavior. That is your diamagnetic. So I've clearly explained both the concepts. One is in video number 30 and one is in video number 31. Clearly, where I showed you what is the hybridization, I showed you what is the geometry of that. I showed you what is why is it diamagnetic in nature. So please go to that video. A clear explanation is given. Go to the playlist, check for that video, and please make your own notes. Right, let us come back and do your 2009 paper. So in 2009 paper, they've asked me what is coagulation process. So I've taught this in video number 18. Please watch that. Here I've also explained what are the different methods of coagulation. Yes. Now next question, what happens in the following activities? Why? They said an electrolyte is added to hydrated ferric oxide solution in water. Okay, so hydrated ferric oxide is nothing but ferric hydroxide. So I've already taught this concept as under peptization. So you're going to watch that video, peptidization, and see how when an electrolyte like FeCl3 is added to ferric hydroxide, it finally forms charge. That's a salt, a colloidal salt. So what are you going to write? A precipitate rather, not colloidal. So usually write it as a precipitate. Then you are going to write that this happens because of neutralization of charges. So once again, watch this video and end your answer like this. You can write because of neutralization of charges. Just write like that and finish off your answer. But watch that video. After writing that, whatever information is given in the video, peptidization, then end your answer with that. Next question, a beam of light is passed through colloidal solution. Okay, they're asking me to explain the concept of Tyndall effect, which I did in video number 14. Next one, an electric current is passed through colloidal solution. So this is the concept of electrophoresis, which I did in video number 19. Please watch that video for complete information. Let us come back and solve your 2011 and 2012 paper. So let us see this. They've given us what are biodegradable polymers. I've already done this as a separate video and the video number 9. Please watch the video. And next they've also given us mention the uses. So basically they're either going to ask you the structures or they may ask you the monomers, polymers or the uses. So uses they've asked for bakelite, which I did in a video number 9, and nylon 6, which I'll be doing it in like I've already done in 2015 board paper with the structure and uses done. So in 2012 paper they've given me define the term homopolymerization, giving an example. Okay, homo means similar unit. So I did that in video number 14. Next comes draw the structures of the monomers of each of the following polymers. So nylon 6, as I said, I did it in video number, or I did it in board paper 2015. Please watch the video. Next comes you.